In this lesson, I'll show you how to solve unusual trigonometric equations. The question reads, determine a general formula or formulas for all solutions to the equation, then determine the specific solutions, if any, on the intervals between 0 and 2 pi. Now, what makes this equation atypical is that on the left side you have 2 cosines, and on the right side you have 1. So if you're untrained with this sort of thing, you might divide both sides by cosine theta and think to yourself that now I have one less cosine to worry about. But the problem with this idea is that if you end up solving it this way, you'll have a few less answers than what you should have. So rather than doing it like this, which is the wrong way to do it, you would take this term to the left side where you have cosine squared theta minus sine theta cosine theta. Essentially, we're grouping all the terms on one side and making the right side equal to 0. Because if you do it like this, now you have a cosine that's in common in both of these terms. So we write down cosine theta within the parentheses minus sine theta is equal to 0. We have 2 factors on the left side of this equation now, and they're both equal to 0. So I'll set cosine theta equal to 0, and this part of the expression equal to 0 as well. We now have to solve these independently, and I'll begin with the easier of the two. Cosine theta is equal to 0. Remember what the cosine wave looks like? It looks like this, and when y is equal to 0, you have x values at pi over 2 and 180 degrees later, or pi later, 3 pi over 2. So theta has to either be pi over 2 or 3 pi over 2, and that fits within the intervals 0 and 2 pi. Generally, what we can say is pi over 2 plus pi k, where k is any integer. And this would be the general form for all of these types of solutions if the wave were to continue. Now for the right side, I'll take this term over. I have cosine theta is equal to sine theta. And dividing both sides by cosine gives us tangent. That's the identity for tangent. So we're trying to find out when does tangent give us a ratio of 1 over 1, essentially. Tangent theta is equal to 1 whenever this angle is pi over 4. And I know that because of the special triangle. That special triangle looks like this, where you have pi over 4, pi over 4, pi over 2. That's the square root of 2, 1, and 1. So pi over 4 plus another pi later on gives us 5 pi over 4. So I have this, that, this angle, and that angle that are between 0 and 2 pi and are answers for this equation. Now generally we can write this down as pi over 4 plus k pi, where k is any integer. That would be considered the general formula. And so there you have it. That is how to solve atypical trigonometric equations.